Hello guys and welcome back to our lecture about object-oriented programming in Python. In the previous lecture, we learned about the basics of OOP in Python. We learned that a class is a blueprint, and based on that class, we can create objects. It means objects are instances of the classes. A class defines attributes, or you can say data, and methods or functions. These data and functions describe an object's properties and behavior. Classes enables OOP principles: encapsulation, abstraction, inheritance, and polymorphism. So we use these four core principles to create organized, reusable, and modular code. In this lecture, we want to study OOP principles, and we will learn all one by one. First, encapsulation. Encapsulation keeps an object's data safe. How? By hiding its internal state and allowing access only through control methods or properties, like a bank account that is protected by a PIN. In Python, encapsulation is achieved using private attributes, using underscore, for example, balance for bank account, and also using properties. We use @sign property decorator to define them, and in this way we can provide getter and setter methods for validation and control. What is decorator? Decorator is a kind of function that wraps another function or class in order to extend or modify its behavior without directly changing its source code, often used for tasks like logging, timing, or even access control. So let's go for coding. We want to have an example, and in here we want to define a bank account class, and this bank account class is used to manage a bank account's balance using a private attribute. So this class provides a getter and setter properties to access and validate the balance, and also it includes methods to deposit and withdraw funds. We will create an account, we will perform transactions, and also we will handle invalid operations like setting a negative balance. So first we will define a bank account class to manage the account balance. So class bank account. First, we will initialize with starting balance, def underscore underscore init, and self and balance. Then we will define a private attribute for balance. So self dot underscore balance is equal to balance, right? So this is a kind of private attribute that we use for balance. So here we will define a getter for balance using a property. And in here, this is a kind of decorator in the bank account class, and we will use it to transform the balance method into a getter property. This allows the private balance that we have defined here, underscore balance here, to be accessed like a regular attribute, like for example, account.balance, while maintaining encapsulation. So def balance self, then here we will return self dot underscore balance, right? Next, we will go for setter for balance with validation, balance dot setter. This balance dot setter is also a decorator in the bank account class, and it defines a setter method for the balance property. We can use this one for control modification of the private balance attribute that we have already. So def balance self and value. Then if value is less than 0, it means it's a negative value, right? So we will raise an error, value error, and we print here balance cannot be negative, right? Otherwise, self dot underscore balance is equal to value, right? This will update private balance. Next, we will go for a method to deposit money. So in here, def deposit self and amount, then self dot balance plus equal to amount, and we can print a message here, deposit successful, and new balance is this one. Then we will go to define a withdraw, and in here we will get self and amount. Then if we will check if the request amount is less than balance or equal to balance, it's okay. Otherwise, there will be an error, right? amount less than or equal to self.balance, it is okay. Then self.balance minus equal to amount. And we can print here something that we draw while is successful, and new balance is this one. Otherwise, if amount, the requested amount is greater than balance, then we will give an error and we say insufficient fund and the correct balance is this much, right? So in this way, we have defined our class. Now we will create a bank account with initial balance. Account 1 is equal to, based on the class that we have defined, bank account, and for example, $1,000 money is there, right? So we want to get the balance. Print account 1 dot balance. How much is it? $1,000 is there. Then we want to deposit. Account 1 dot deposits. 500 we want to add, so 1,500, right? Account 1 dot withdrawal, and we want to take 1,200, so it says 300. So I have 300 balance here. Account 1 dot withdrawal, and I want to take 400. There will be an error, insufficient fund, current balance is 300. Let's try for this error, negative. So for example, here I say try account 1 dot balance is equal to minus 100, except value error as E and print error E, right? Balance cannot be negative. This message that we have defined here. So in this example, we showed encapsulation and we used a private attribute here, and also we use properties to control access. This property that you can see here, it's a kind of decorator that allows balance to be accessed like an attribute, while this balance.setter ensures validation to prevent negative balance. The next core principle of object-oriented programming in Python is abstraction. Abstraction hides complex details and show only the essential features. For example, you have a TV remote. This TV remote lets you change channels without exposing its internal circuits. You don't know what is going on inside that remote, just you use that one to change the channels, right? In this example, we want to define an abstract-based class like shape, and we have an abstract like area method that we implement by concrete subclass like circle or rectangle to calculate and return their respective area for each shape. So for that one, from ABC, we will import ABC abstract method. So here, I'm going to define an abstract-based class shape. Class shape, and this is ABC, right? Abstract method. This is an abstract method for area that must be implemented by a subclass, right? Def area, self, and pass. So it must be defined. I will explain more later. Next, I will define a circle class. Class circle shape, and in here def init self. So in order to calculate the area for the circle, we need to know the radius, right? I need to get self.radius. Radius is equal to radius. Then I will calculate the area. So I will define a function to calculate the area of the circle. Def area self. And in order to calculate this area, we need pi, import math here. So, okay, then here, return, what is the area of a circle? Pi multiply r square, right? So math.pi multiply self.radius square. Then I will go for class for rectangle. Class rectangle, and it's a kind of shape. And in here, again, def init self width and height, then I will get self.width is equal to width, and self.height is equal to height, right? Then I need to define a method to calculate the area. Def area self, and what is the area of a rectangle? Width multiply height, right? Self.width multiply self.height, right? Finished. So our class is defined here. Now I want to create instances of the shape that we have. So one instance is C1 is a kind of circle and with the radius of 5, right? And a rectangle 1 is a kind of rectangle and with the, so we need to have width and height, right? For example, 4 and 6. Now I want to calculate the area for circle and rectangle. Print if circle area is C1 dot area. So we have 3.14 multiply 25, it is 78.5. In this class, we show the abstraction by using an abstract shape class with an area method that subclass circle and rectangle. It's a kind of must implement, right? This one force them to implement the area here. So the user here interacts with the area method without needing to know the underlying calculations. So just we will go for this one. We don't need to know what is going on here. The third core principle of OOP in Python is inheritance. Inheritance lets one class borrow attributes and methods from another class. For example, a child inheriting traits from a parent, and this inheritance promotes code reuse. In Python, a subclass inherits from a parent class using the class definition syntax like super. So I will explain in this example. In this example, I'm gonna define an employee class that initializes employee object with attributes like name and pay and provides method for generating full name, applying raises, and custom string representation. We wanna overload operators to some salaries and return the length of an employee's full name. To do that, we create two employee instances and print their combined pay and one employee's full name length. Okay, here we define class and the name of class is employee. Then in here, we consider that the raise amount in general is 4%, right? We define initialization def underscore underscore init underscore underscore here self, first, last, and pay. So in here, self dot first is equal to first, self dot last, we initialize last name is equal to last. Then we initialize pay, self dot pay is equal to pay. And also self dot email is equal to first, f first, then dot last, last, and here at sign, for example, email.com, right? Then here we define full name. Full name we get self, and in here we return full name. So return if self dot first and self dot last. So this returns full name. Then we define apply raise, and we get self. So here then self.pay, we apply raise. Self.pay is equal to integer part of self.pay multiply self.raise underscore amount, right, by default. So this is an employee class. Then we will define another class for developer. So class developer, and this one is a subclass from employee. By default, it was 4%, but in here, we will change it to 10%, right? So this is higher rates for developers. Then again, initialization, def init self, first, last, pay, and we have a new parameter here that is programming language, right? So here we go for super. This super invokes the employee class init method to initialize the inherit attribute like first, last, pay, and email. And this ensures proper initialization before adding the programming language attribute, which is specific to the developers. The use of this super practices dots promotes code reuse and maintains the parent class's functionality while extending it in the child class. So super dot init, and in here first, last, and pay. So we call the parent constructor. Then in here we add programming language self, prog language is equal to programming language that we have defined. That's all. Now here we're gonna create some instances. So E1 is equal to employee, and we can decide some name for it like John Smith with 50,000, right? Now we can add 4%, right? So in here we said 4%, right? So in here, employee E1 dot apply raise. So let's see here, and now we can print the E1 pay, which is 52,000. So 50,000, 4% added, 52,000. Now we move to the developer class. So D1 is equal to developer. So developer, and we can decide some name for it. For example, Lee and Park, and here like 60,000, and the programming language is Python. Then we can do the same here. In this time, D1 dot apply raise, and we can print salary for this one, D1 66,000. Or we can print, for example, print what is the D1 programming language, right? So programming language is Python. So in here, we can add another function, and we overload plus operator to some salaries, right? Def underscore add. Then here we get self and other. Then what we do here, we return self.pay plus other.pay. And also here, we can overload length function to return length of a full name. For example, def underscore length, then self, and here we return length of self dot full name, right? Okay, that's all. And employee class will be the same. I want to print combined pay using our loaded plus operator that we have defined. Print if combined salary is combined salary of E1 dot full name, and D1 dot full name is E1 plus D1. So combined salary of John Smith and Lee Park is 118,000, right? Or I want to print length of one employee's full name using the overloaded length, right? Print if length of E1 dot full name, and we add one s here, name is length of E1, right? So length of John Smith name is 10. Print if employee, then E1 dot full name, E1 dot full name, E1 dot full name, and then email is E1 dot email, and that's all. So you can see here, employee John Smith, and email is john.smith@email.com. Or the same we can do for the developer. So D1 and here D1. And you can see employee is Lee Park and email is lee.park.email.com. This example shows the inheritance by having the developer class inherit from employee. The developer class reuses the parent's attributes and methods, override the raise amount, and adds a programming language attribute using the super, this one, super that we have defined here. This is used to initialize a parent's attributes. The last but not least core principle of OOP is polymorphism. Polymorphism allows different classes to be treated as instances of a common parent class. For example, how animals make different sounds, right? Cat has its own sound and dog has its own sound, but they are in one class of animals. Polymorphism can be achieved when subclasses override methods. So in mathematics, we have a concept of complex numbers. Complex numbers are numbers with real part and imaginary part. For example, you can say a plus bi. In here, a is the real component and b is the imaginary component and I is the imaginary unit. And we can say, like, for example, I square is equal to -1. right? In this example, we're going to define a complex number class to represent complex numbers. This initializes them with real and imaginary parts. And also we want to overload the sum operator to add two complex numbers. And also we provide a string representation. For example, we want to have 2 plus 3i, right? This one plus 4 plus 5i, right? Which equals to 6 plus 8i, right? So we want to do this calculation. Class complex numbers. And in here we go for def, init, self, real, and imaginary. Then self.real is equal to real, and self.imaginary is equal to imaginary. Next, we define method to overload sum operator, right? Def add self and other. Then here we add the real parts. Real is equal to self.real plus other.real. Imaginary is equal to self.imaginary plus other.imaginary. Then we return the result. Return complex number, real and imaginary, right? It will return a new complex number. Okay, then we go for the string representation. Def str and self. Then we return self.real plus self.imaginary, and we will add one I here as well. So it's finished. Our class is finished. Now we can create complex number instances. C1 is equal to, for example, complex number of 2 and 3 and 4 and 5, right? 2 and 3, 4 and 5. So these are the two complex numbers we have defined. Then we go for result. Result is equal to C1 plus C2, and we can print results, right? So it will show 6 plus 8i. So in this example, we defined one class complex number in order to add complex numbers together, real part together and imaginary part together. Then we define this string method in order to present the string presentation of that one. And in this way, we can print the result. Okay, thank you very much for your attention. In this lecture, we learn about core principle of object-oriented programming in Python. We learn about inheritance, polymorphism, encapsulation, and abstractions. Please practice and feel free to ask me your questions by leaving a comment below this video lecture. Thank you and see you in the next lecture.